All right, so function experts, if you need a pencil, there are some on the bottom shelf. If anyone needs a pencil, there are some on the bottom shelf there. You can grab one. The question's asking, when does a graph represent a function? And it says a function is a relation in which every input is matched with exactly one output. So what we need to be doing is we need to be checking the inputs to make sure that they don't have a different output for the same input. So it says up here, these are functions and these are not functions. So notice here, all the inputs are different, -2, 0, 1, 5, all different. But here, I have 2 inputs, and do they have the same output each time? Only function experts. Can you answer me? They don't, right. So you can circle here. When you input a 0, you don't know if you're going to get out a 2 or if you're going to get out a 4. Like, that is not a good machine if you input a 0 and you're getting different things out each time. So where it says YNAP, you're going to write, when you input 0, you could get different outputs. Okay. If you're a function expert and you have a question on that, raise your hand. Okay. All right, so we can also look at graphs. This graph is a function. You can see a point here, 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 and here. This graph is not a function. I have points here, here, and here. Because remember that points have numbers on them. So this is -2, 3. This one is 0, 2. And this one is 0, 4. And then this one is 1, 5. So notice that when x is 0, I could have an output of 2, or I could have an output of 4. It's actually the same as this table here. All right, has anybody learned the vertical line test before in their algebra class? Raise your hand if you learned that. Vertical line test. You did, good. So it can be useful, it's kind of a shortcut to see if there are 2 x's with the same y. If you draw a vertical line that can go through 2 points like this and this, that means it is not a function. So for your reason, you can either put, when you input 0, there are different outputs, or you can put it does not pass the vertical line test. The vertical line should cut any point exactly once. So see here, only 1, only 1, only 1, only 1. But this is 2. Okay, but really this reason can be the same as this reason too. I just wrote that because it was new information for us. So for the third one, function experts, what do you guys think? Do you think yes, it's a function, or no, it's not? No. Hey, Lonnie says no. Anybody else have an opinion? Kenny says no. Should we do a vertical line test to see? Yeah. So you can do a vertical line test. And if you pass 2 different points, that means that when I input 2 as my x, there are 2 different values for y. So you can say the same reason, or, and you could have drawn your vertical line in lots of different places here, but I drew it here, so I could say when 2 is the input, there are different y values. You can see them here and here. So remember that after we do this front page, you need to feel confident enough that you'll be able to teach your partner, okay? But you don't teach them yet, because I'm going to teach your partner about inverses so they can teach you. All right, so we have a real life example. If a Coke machine did not act as a function, what problem might occur? Think about that for a minute. If I press the button for Coke, what problem might occur if it's not a function machine? Who has an idea? Kenny, go ahead. It could give a different soda, right? So like one day it might give Sprite, and then the next day it might give you Fanta, and then the next day maybe it gives you Coke. So if it's not a function machine, the input of pressing the Coke button would give you different outputs, which is not reliable. Like sometimes you want to be surprised, but most of the time when you go to the Coke machine, you want exactly what you want. All right, you don't want to be surprised. So let's write that out. You can write it in your own words. I'm going to write it in my own words. All right, so we're going to use, oh, you guys can't see it. We're going to use this idea of unreliable when we're advertising your function machine. Because you want, your function machine is going to be a genuine function machine. It is going to be reliable. But your competitor, they're not going to be reliable. So you're going to talk about some competitor for your company that is not a genuine function machine. All right, so I'm going to ask you to take a minute and try those on the bottom before we go over them. Just tell me yes or no if they're functions. Feel free to talk to any other function experts. So Kenny, Jason, Elias, Danny, Kai, Nadim, Elisa, and Lonnie. You can talk to each other. And we'll go over them in just a couple minutes. First one, guys. Did you say yes or no? No. I heard 2 votes for no. Anybody else have a vote? No? Okay. And what's the problem with this one? Which X value repeats?
1.
Yeah. And it repeats with different outputs, which is no good. Okay, for the second one, what did you guys put? Yes, also no, because you can find 2 X values with different Y values. Make sure that you're writing on it so that you can use it to explain to your group, your partner. Next one, what did you guys say? All right, so Lonnie feels pretty sure about that, even though we didn't have any examples of this type. Does anybody else think it's yes? Kenny does? Okay, it is yes, because remember that you could always take these points and put them in a table. So you've got 0, 3, 1, 4, 2, 5, and 3, 4. And then it's kind of easy to see none of the X's are repeating. So every input has its own output. How about the last one? What did you guys say?
Yes.
1 vote for yes, 2 votes for yes, 3 votes for yes. Okay, it's right. Because anywhere I draw a vertical line, it will only cross it once, which means every X has just one Y. So this is also a yes. Okay? Now, I do not want you to do the problems on the top here yet, because I want you to work through those with your partner as you're teaching them, so don't do them yet, okay? What I do want you to do is I want you to go back to Schoology, and I want you to work on the project brainstorms in day 1. You want to open that one up, and you're going to use it to help you with the day 4 activity, which is here. The project planning, okay? Now remember that your partner has already started on this, so if you get stuck, if you're like, I'm not really sure what I'm supposed to be doing here, you can also ask your partner. Okay, and experts 2, I'm going to have you guys pause your work in the project planning so we can do notes. So expert 2's, your paper looks like this. Let me pull back this. Okay. So I'm going to come around. I want to see the expert 2's are ready. Expert 2, if you need a pencil, there are some in this pink bin on the bottom of my shelf. Let me just make a quick trip around to make sure everybody is ready. You got to change gears. It's okay if you didn't finish your project planning, but I need you ready to do the notes now, okay? Your pencil? Okay, so next thing you're going to do is do the project planning sheet. This one. And then you're going to teach each other after I teach her. Okay? Yeah. Oh yeah, you don't have to do that yet. No, we don't need that yet. Go and just, well, okay, don't do it now because you're going to do this now. And I'll help you with that after, okay? Alright. Alright, so Emma, you look ready. And Dion, you're supposed to be doing project planning. Can't take the whole thing, take one. Okay. Yes. So your divisions are upside down, but everything else is looking good, okay? All right, and we're going to do this together. I just want to see that you're ready. Ready? Shelby, are you ready? Yeah. All right. All right. If you already worked on it, then please check your answers as you go. So an inverse undoes an operation. So for example, the inverse of go left is go right. You see how that undoes what I just did? Okay? So inverse undoes an operation. So I gave some examples there. Inverse of x plus 5 is x minus 5. Inverse of x minus 4, what would you guys say? What would undo minus 4? X plus 4, very good. Okay. Now remember that this looks like a fraction, but it also means what operation? Divide, good. So the inverse of x divided by 3, what would undo that? Is he right? X times 3? Yeah? Okay. And remember, we're just going to start with the y equals. So you could write like x dot 3 like this, but most of you remember that in algebra, it's more common to write 3x. They're both right, but 3x is just more common to see. All right. And then the last one says 5 times x. So the inverse of 5 times x is what? Okay, so the inverse of multiplication is division. That's very good. But the one thing that's tricky is that we have to be careful with the order because we want to start with the x and then divide it. So instead of 5 divided by x, how could we re-say it? Beautiful. Okay, so inverse experts, I'm going to say your name. You let me know thumbs up if you're good, or just give me a hand if you need a minute to think, okay? Shelby, thumbs up or you need a minute, okay? Kelly, thumbs up if you're good or hand if you need a minute. Good, thank you. Kevin, good. Dion, okay. Johnny, good. And Joseph, good. Nicole, are you ready, Nicole? No. Not yet? Okay, get your pencil up. Stephanie? Okay. All right. How do you find the inverse of a multi-step equation? So here are the directions to get to the entrance of the new wing. From my classroom, you'll turn left, walk north, turn left, walk north, turn right, and then walk east. If you want to go backwards from the entrance to the new wing, you have to reverse your directions. Would I start by doing inverse of step D, or do I start by doing the inverse of step A? If I'm already at the entrance and I want to go backwards, should I start at D or should I start at A? So if I, yeah, I'm going to start at D because I'm already there, so I need to go backwards. So I have to start with step D, and then the inverse of walk east is walk which way? What's the opposite of east? West, good. So I'm going to start with walk west. And then instead of turn right, where do I turn? Left, good. And then walk north, so I need to walk which way? South, good. And then instead of turn left, I need to turn right. And that should bring me to the door of this classroom. Okay, walk west, turn left, walk south, turn right into the classroom. It works. All right. So the same thing happens with inverse of a two-step equation. When I do the inverse of y equals 2x plus 8, originally I would multiply by 2 and then add 8, right? Let's see. So then I need to do the inverse of that. What's the inverse of add 8? Subtract 8, good. And then I need to do the inverse of times 2. What would that be? Yeah, the inverse of times 2. Yeah, divide by 2. So the order is important. You have to do the backwards order of what you did before. So you start with the y equals, and I need to do x minus 8 first. That's this one? Oh, yeah, sorry, guys. Thank you. So I need to do x minus 8 first. And to show that I have to do that first, I'm going to put parentheses around it. And then I'm going to divide by 2. And you can do a division sign like this, or you can do the slash that we were using before. Either one's fine. Or you could even make it a big fraction. All right, so you don't have to always write the words out, but you do want to remember that you have to undo the thing that happens second. You have to undo that first. So I would like you guys to take a minute and try these two at the bottom. I'll come around and see who needs help. And also those of you who are working on project planning, if you have questions about that, I can answer those too. So let me pause my video. Okay, so for this one, which one do we undo first? Do we undo the times 3 or the minus 5 first? The minus 5, because we're working backwards. So I'm going to put the y equals, and instead of minus 5, I'm going to have what?
Plus 5.
Good, so we're going to do x plus 5. Now, a lot of you guys had that, but a couple of you did forget that we want to put parentheses around it to show what happens first, okay? And then, how do we get rid of the 3? Divide by 3, good. And you can do this kind of divide, or you can do this kind of divide. It doesn't matter. They both mean divide. Questions on that one? Okay. The next one down here, do we undo divide by 2 first, or do we undo plus 1 first? Plus 1, good. So we're going to have y equals x minus 1 and parentheses. And then we need to do what with a 2? Multiply, good. Now, you're multiplying all of that by 2. Some of you guys put the 2 in front, which is actually how you would see it more. And some of you put the 2 in the back, and it does not matter. You just need a times 2, okay? I kind of ran out of room, so I'm putting my times 2 here. But if you have your 2 in front of the parentheses, you're also good. And that one is actually probably more accurate. I don't want you to work through any of the problems on the back yet, because we're going to do a quick break. And then after the break, the function partner is going to work through this with you and explain it to you. And then the inverse partner is going to work through this and explain it to the function partner, okay? So you're going to work together with a partner. So don't do these problems yet. You can look at them, but don't write on your paper yet. You'll be writing on your paper as you work with a partner. We're going to do a break, and then after the break, we'll do that.